Okay, in this video I'm going to be doing an example of linear regression in Excel. And so I'm going to be showing you how to compute the coefficients for a line. So just remember we're doing linear, I'm in a different color here. If we're doing linear regression, then we have some data set that has a linear trend. So some data has a linear trend, and we're trying to find a line that best captures that trend. And what that means mathematically, if our data here, this is y and this is x, so we've got a bunch of data points. We've got a bunch of x1 comma y1 pairs, so maybe this is x1 y1 right here, and then we've got another point x2 y2, etc., all the way out to xn yn, where we've got, if we have n data points, right? So this is what our data looks like. This is our data. Okay, and we want to find the line. I'm going to just call this, I could say w of x is this function. It's the function of a line, a naught plus a1 x. So it has this is the y-intercept and this is the slope. And so I showed in a previous video that if we minimize the error, the sum squared error, if we minimize this with respect to a naught and a1, then we get these equations up here for a naught and a1 in terms of our data. So this is our data. So n, the number of data points, times the sum of the x data times the y data. So I'm going to show you how to calculate a1 and a naught in Excel. Also, I'm going to show you how to compute. I'm going to show you how to compute this, and then this, and then the r² value for that fit in terms of ST and SR. So ST and SR are defined here. I've got the equations down. So let's go ahead and jump over into Excel. I'm actually using LibreOffice. So I'm going to show you how to do it in LibreOffice. Let's see if I can make this, resize this in a way so that we can see the equations. Alright, we'll start off with like this. Alright, so first I'm just going to generate some data. So let's use 10 data points, and so I'm going to use some x data. I'm just going to call this xi. This is going to be yi, and the data points, I'm going to go 1, 3, 5, 7, 10, 12, 13, 16, 18, and 20. Okay, just 1 second here. Alright, now let's go ahead and put in the y data. So let's say we have values of 4, 5, 6, 5, 8, 7, 6, 9, 12, and 11. Okay, now let's just go ahead and give us a little bit more let's just plot this data here. Let's make this all centered here. Alright, let's plot it. Let me see here. Insert. It's right here. Chart. I want a scatter chart like this. Well, it's big. And let's make it smaller. Alright, now we can move it right down here. Now you can see here, if I click this data, I can insert a trend line, and I want it linear, and I want to show the equation and show the coefficient of determination. Oh, that is ugly. I guess we've got to make it bigger. Let's at least make it wider. Alright. Now, here's the equation. So you can see it fits this line down here, and it gives us an A1 value of 0.37249666622 times x plus an A0, which is the y-intercept of 3.3887850467. And here's our r-squared value, our coefficient of determination. So I'm going to show you how to calculate these using the equations, and we should be able to get the exact same thing that your spreadsheet program gives you. So I'm going to move this down here kind of out of the way a little bit, come back up here to our data. Now, in order to calculate these values, we need to calculate A0 and A1, and we need the sum of xi times yi. So I'm going to go ahead and create an xi times yi column, and I'm also going to need to calculate xi squared, so I'm going to put an xi squared column. Okay. Alright, so let's go ahead and calculate those in terms of our data. So this I'm just setting equal to, I'm going to highlight the xi data, and then times the yi cell, hit enter, and then this one is just going to be equal to xi squared. Now I can take these two and drag them down so that I get my data values. And here, I'm going to put a line on the bottom here. Let's see, where's my little, I don't use this program very often, so I'm not very familiar with it. Where's my little thing that allows me to box my cells? Oh, here it is. I'm going to put a line down here on the bottom. Okay, now down below this line I'm going to keep track of the sums and the means. Okay, so this here I'm just going to say is equal to the sum of the above column. I'm going to come up here and highlight my x data, close parentheses and hit enter, and then I'm going to drag this across. So these are now the sums. Okay, here, let's go ahead and do this too. Let's make this look a little bit nicer. Let's put a line at the bottom. Alright, so I have my xi data here, and the sum of xi right here, sum of yi, the sum of xi yi. So here, let's just put these down here. Xi yi, xi times yi, xi squared. Right. just so that we can remember. Alright, now the means here, I'm just going to calculate the mean of xi, that's x bar. That's going to equal the sum divided by the number of data points, which is 10 data points here. And this one is going to be equal to the sum of yi divided by 10 as well. Alright, so now we got our sums. So we've got everything we need to calculate a0 and a1. So a1, I know n is equal to 10. I have the sum of xi, yi, the sum of xi, the sum of yi, sum of xi squared. I have y bar and I have x bar. This is the mean of y and the mean of x, arithmetic mean. Alright, so now let's go ahead and calculate our values for a1 and a0. So I'm going to say a1, I'm going to store down here an a2, and let's take these, and I'm going to just box them here. Alright, so let's calculate a1 first. This is equal to n, so we got to put 10 times the sum of xi, yi, which is right here, minus the sum of xi, which is right here, times the sum of yi, which is right here. Take that whole quantity and divide it by the quantity n, which is 10 times the sum of xi squared, which is right here, minus the sum of xi squared. There we go, 0.37249, which is exactly what we got down here. Okay. Now we can calculate a2. A2 is going to be equal to y bar, which here's y bar right here, minus a1 times x bar, which x bar is right here. There we go. We get the same y-intercept as we got for that our spreadsheet program gave us. Alright, so now there we go. We found our parameters for our line that that give us the best fit in terms of the sum squared error. Alright, so now here I'm just gonna move this down one, maybe even one more. Oh. Alright, so now what we need to do is we want to calculate the r-squared value. So remember there was an r-squared value here that tells us it's a measure of the goodness of the fit. And so the r-squared value, let's take this and move this up here. And let's see if we can grab this and bring this down so we can see the equations for r squared. Alright, let me bring this back up. Alright, so now we can see the equations for r squared there. We need to calculate st and sr. So I'm going to do that over here, and I'm going to put the error about the mean, about y bar, and then error about the regression line. Okay, this is going to be equal to the error about y bar, so squared. So we take y, our y value. So actually we need to open a parentheses because we're going to have to square the error, right? So open parentheses, our y data minus y bar, which is we calculated down here. So y bar, and we want to make that absolute. I'm trying to remember how to do that. Oh no, that didn't work. I want to make this absolute. Well, I can do it by hand. I just got to put dollar symbols in here, okay? And then square it. And then this one, error about the regression line, we're going to have to use our values here. So we just calculated ST for 1 point, for the first point. Now we need to do SR for the first point. So for I equals 1. Here, this is going to be equal to our Y data. Now we're going to subtract off A naught, and we want to make that absolute. Oh. No, we want this one. And then we want to make this absolute. And then we're going to subtract off, add on. So we need to add A1 plus XI. Add A1, but we need to make that an absolute reference. So put in the dollar symbols times our XI data. And then close our outer parentheses and square that. Alright, now we see the error about the regression line is a lot smaller than the error about the mean, which is what we would expect. So now let's generate all this data here. And I'm going to just make this look better. Let's put some bars here. Alright, so now let's calculate the sums up here. So we've calculated the error for each data point. Now we need to sum up the error. So this is going to be equal to, down here we're going to have S sub t and S sub r. And might as well put some nice boxes around these two. Alright, and so this is going to be equal to the sum of this entire column. And then we'll just drag this over to get the sum of SR. So we see the sum squared error about the residual is a lot less, about almost 6 times less than the sum of the squared error about the mean. Now if we want to calculate R squared, say R squared, and we'll put it over here in this cell. This is equal to S sub t minus S sub r divided by S sub t. And we get 0.81065, which is the same as this R squared value here. Alright, so that's the example. We can look at it kind of all together now. Hopefully that kind of helped you understand from a real numerical example how we actually calculate the regression line, the linear regression line, and the R squared value. And we'll see you in the next video.